we'll do what we can this morning and this afternoon, and you can ask more questions on the forum. So managing mathematics in WeBWorK. So we've talked about the structure of a problem in the past. A WeBWorK problem is written in a dialect of the Perl programming language, so I'll talk about Perl. This dialect is called PG, and most WeBWorK problems include the following kinds of things: a document call, a load macros call, text begin problem. We've done this in the problems you've written. Section where your values are initialized, section that creates the text, section that defines the answers, section that gives solutions, and then followed by an end document. Oh, there should not be an underscore there. It's end document without an underscore. So the PG language lets you do all these things, and PGML, the markup language we talked about last time, combines these two sections into one piece. All right, so here is a typical problem template: document, load, macros, begin problem. Your initialization values go here in this red section here. The begin PGML, end PGML is where your text is. You can say whether partially correct answers are shown. So if you have several answer blanks, what kind of information do you want the student to get if some of the answers are right? And your solutions go down below. I do want to talk just briefly about load macros here. PG standard loads in a bunch of macros that you almost always want to use. So putting PG standard first in your load macros is a good idea. Whatever other files like pgml.pl, MathObjects.pl, and so forth go in between here. And the last one you have ought to be pgcourse.pl. pgcourses starts out as a blank file, so nothing actually happens here, but it's something that you can override in your course to make modifications to the way problems are handled on a sort of a course-by-course basis. If you have this in the problems you make, you can take advantage of it. If you don't load this file, then your modifications won't be loaded. So you should put this as the last file that you put in your load macros call. You should always include it because we're trying to get people to be consistent about doing this. And it should come at the bottom, not above other things. One of the things that's there to do is to make modifications to other things. For example, if you do vector notation in a different way from the way MathObjects does by default, you could set in your PG course file options that would turn on a different way of displaying vectors. Or if you use complex J instead of a complex I, like some engineering groups do, you can set that up in your PG course file. But if the PG course file isn't loaded into a problem, those changes won't take effect. So you want to be sure to include this and put it at the bottom so that it can affect everything else that gets loaded. All right, enough said about that. So this is the structure of a problem. We've seen that in the past. Here's an example problem. Consider a function, find its derivative, and find its derivative at a particular point. So in these slides that I'm showing you, there is when you see a problem like this, there's often a show problem source button here. But we will get that later on. So mathematics. MathObject library is about mathematics in Perl. Perl, again, is this language that you've been writing your problems in. Perl's native support for mathematics extends only to real numbers and to functions of real numbers. But we want in WeBWorK to be able to talk about complex numbers and vectors and points and matrices and lots of other stuff. Perl can load libraries that can add new features to the language via this load macros call. And WeBWorK loads a number of these and can be configured to load more of them. MathObjects is one of the ones that you can use. MathObjects is a package that extends PG's capabilities to include mathematical constructs like complex numbers, the ideas of infinity and negative infinity, things like points and vectors and matrices, things like intervals and unions and sets of real numbers, arbitrary words, things like none or does not exist, or other kinds of things you might need in your problem. things like lists of values, so lists of numbers or lists of points, or you could ask for where is this function undefined, and the student would have to type in as many x values as there were, and then formulas as objects themselves. The idea behind MathObjects was to provide a unified approach to mathematics within a problem. There's a bunch of things that talks about. One of them was that professors and students work with the same notation. So the algebra notation that we talked about with PGML is the notation that students enter their answers in. The professors can enter their answers in that same format. That way the students and the professors work the same way, and there's no chance of there being a difference in how that works. And in the old days, before MathObjects, the way you entered things in the PG program was very different from how a student did it. And that caused lots of problems. So this unifies both forms. The professor and the student can enter things in the same way. These MathObjects can produce check versions of themselves, or string versions, or even Perl code from them. And so the same original form gets you all the possibilities. Yet in the old days, you had to have a Perl version of a function and a string, the algebra version, and a tech version, all separate. And that meant if you edited the problem and you forgot to edit all three things, that things would not be consistent. So this allows you much more consistency in your problems. These objects know how to check for their correct answers. So you simply ask the object to check the answers for you. You don't have to set up a checker directly. This one about error messages, this is the thing that I really was after when I wrote this, which was that error messages need to be consistent for the various types of answers that you can get. So, for example, in the problem we looked at, we had a formula where asked for its derivative and its derivative at a particular point. We'll go back to this in a second. So formula and a formula at a point. This formula is supposed to be something that involves x's, but this number is supposed to be just a number. And in the old days, you would use two different kinds of answer checkers on these two, and the one that expected a number would give you an error message if you typed an x in there. It would say x is unknown. And to a student, this is very confusing because x is perfectly well known. X is a variable in the problem, and x means something to the student. So being told x is unknown is a source of confusion. So both of these answers have to know about the fact that x is a variable in this problem, and they should both treat x in a reasonable way. And the second answer should tell you something about you shouldn't be using x here, not that it's unknown. And so one of the things I was after was to try to coordinate the error messages so that they were reasonable error messages no matter what was going on. We'll talk a little bit more about that later on. And I still think this is a really important thing that you need to be thinking about in your problems, is what kind of error messages are students going to get when they type wrong things, because you know they're going to type wrong things. So the more help they can get from the error messages that your problem produces, the better off they'll be. Another thing that MathObjects allows you to do is to override the checkers with your own custom ones. We talked a little bit about this in the breakout group that I was in. That's going to show up later on in the next week, I think. And finally, objects can be extended to make special purpose versions of them. That is, you can make, if you have something that acts like a real number most of the time, but it is somewhat different, say a integer modulo some other integer, you could make a subclass of the number class and have it have additional properties to it. This is very much a advanced topic, not something we're going to cover here, but it's something that I do a lot of. As people ask questions, I make a new version of a math object that has the properties that are needed for that. So this library lets you extend the capabilities of WeBWorK in a reasonable way. All right, so enough of that. How do you use the bloody things? Well, loading MathObjects into your WeBWorK problem is easy. You simply include MathObjects.pl inside the load macros call at the top of the PG file. So here is an example like what we were talking about before.
Right. David, now I think your share starts to work now.
Let's give it a shot. Yay. Thank you, Gavin. I appreciate that. All right, so I will use that shortly. All right, so MathObjects try to consider the problem as a unified whole rather than a collection of unrelated answers. So I was talking about this a minute ago in terms of the fact that this answer blank for the first part of the question, it says, what is f of 2y if f of x is 3x to the third minus 3xy squared? If I plug in 2 for x, what do you get? Well, you should get a function of y, so we'd get, 8 minus, 3 times 2 should be 6y squared. So we should get that. And if we ask the answer checker, that's correct. But the second one should just be a number. Now, if I, as a student, don't understand how this is working, and I end up with something with x's and y's in it still, we ought to get something reasonable out of this that says your answer isn't a number, it looks like a formula that returns a number. So this at least is telling the student something about what they've done wrong. Their answer should be a number. It doesn't say something confusing like x is unknown. X is not unknown to the student, but it's not something that should be in this answer blank, but it's part of the problem, part of the whole problem. The context of the problem includes x's and y's. And so x's and y's should not produce errors about being unknown here. They should try to tell you, oh, it looks like you're typing a formula when you should be typing a number. So that's what I mean by unifying all of the answers in here. If we happen to be working with points, then a point in this location ought not to say, I don't know what you're talking about. It ought to say something like, this shouldn't be a point, it should be a number. And the information about how the problem works is stored in something called the context, the MathObject context for the problem. So MathObject contexts store information about what the student is allowed to talk about in the problem, what the author is going to talk about. So things that are in the context are things like the names and ranges of the variables, the names and the values of constants like pi and e, the available functions like sine and log, the various operations that they are allowed to do like plus and minus, the way the parentheses work. For example, do parentheses create a point, or do they create an interval? That's an important distinction, and the context of the problem will tell MathObjects which of those kind of things you want. They include things like the various words like none and does not exist that you might have that the student could type, and they include various settings like the tolerances for how close the answers have to be, or the formats in which numbers will be displayed, and so forth. So the context controls a lot of global stuff about the problem. There are predefined contexts for a number of situations. So if you want to specify one, you use the context command and you pass it the name of the context that you want. And the main contexts that are predefined are the numeric context. This has a single predefined variable x. You can add others or remove this one if you want, but you're not allowed complexes or points or other kinds of things. So this is a numeric, simple numeric situation. The complex context has a variable called z. It has a constant called I, which is the square root of -1, but it doesn't allow points or other kinds of compound structures. There's a point context and a vector context that have variables x, y, and z in them. Angle brackets form vectors. Parentheses form points. I, j, and k are defined as the unit coordinate vectors, and so on. Points are like vectors, but without the angle brackets and vector functions. There's a vector 2D, which has the same as vector, except I and j are two-dimensional instead of three-dimensional. That's basically the only difference. There's a matrix 1, square brackets form matrices. There's an interval context where parens and brackets form intervals instead of points. And then there's some complex versions of point vector and matrix. Now, before we go too much farther, I did want to remind you, you don't have to remember all of this. What we're trying to do today is give you an overview, give you a sense of what's available so that you know what possibilities there are, but you don't remember the details of that. Once you need to do a problem and you say, oh yeah, I remember there's something about contexts that are special for vectors, then you look up the details of how to do that. So today, this is not memorize all of this material. This is knowing what's possible, that it is possible to do these things so that when you need to in your problems, you say, oh yeah, we can do that somehow, and then find it from the documentation. All right, so these are the predefined contexts. There are lots of others. And here's how they get used. So in your problem, in gray is sort of the main problem. This was the one with the derivative formula that we had in the first one. Here is the line that says we're talking about simple numbers, not complex numbers or anything more complicated. The problem also, you can read through this problem and see the PGML here that lays it out. We'll be looking more at the different parts of this problem as we go along. There are other special purpose contexts available as macro files that you can load as needed. And these include a bunch of things like specialized string contexts. For example, if you want students to enter a selection from answers A, B, C, or D, they want to be able to type A, B, C, or D and really nothing else. So there's a special context that says if you type something other than A, B, C, or D, it says your answer should be one of A, B, C, or D. And of course, you could add or remove the letters that you want. You could add E and F if you needed to, or remove D if you needed to, and so on. There are special contexts for true and false, and other kinds of situations like that. There are contexts that limit operations to produce what are called strict checkers. So that, for example, if you were asking for the sign of pi over 3 and you didn't want them to be able to enter sine of pi over 3, you wanted them to enter the numeric answer, you could have ones that don't allow functions, certain kind of functions, or that don't allow addition and subtraction. If you want to be testing, can they add? You want to add, say, what is 3 plus 4? You don't want them to type in 3 plus 4. You want them to type in 7. So there are ones that restrict the various operations or functions that are allowed in the context. So those are called strict checkers. There's context for special purposes like currency or scientific notation or factoring polynomials. There's even some for chemical reactions. There's things for permutations and cycles. There are other specialized contexts, lots of these. You can find these at this link. This is the actual source code for WeBWorK, and this is the macros directory. You have a copy of this directory when you install WeBWorK. And anything here that starts with context, like here, context ABCD, is a context that has special properties. ABCD is the one that allows you to type in those letters. There's ones for using commas as decimal points for European use. There's one for intervals that use the backwards brackets for open and closed. That's again a European one. There's ones for using complex J instead of complex I. Here's currency, here's fractions, inequalities, set builder with inequality notation. There are limited complex numbers and numerics and points. These are the ones that reduce what you can do when you have to put them in certain formats. Here's one for an arbitrary ordering, a partition, percentages, permutations, piecewise functions, polynomial factors, rational functions, chemical reactions, scientific notation, all kinds of different specialized ones here. And these things, if you look at them, at the top, there should be documentation saying how to use them. So you can look up how to use them here if you need to. There's also that documentation for most files is available on this link. Down here are those things like context inequalities. That documentation has been put into a more web-like form. So you can read about how to use those particular extensions to the MathObjects library. So a lot of them, and you might need one or two of them as you work. All right, so here's an example. Context-limited polynomial implements a context in which only polynomials may be entered. So you may want to say x plus 1 squared is, and you want the student to write out the polynomial in standard form. So I can't type x plus 1 squared. I can type it, but when we get this, this will say you can only raise a variable to the power in a polynomial, not, in this case, this linear term. So I can only use powers on x. So I would have to type x squared plus 2x plus 1 for this. And that should get me a correct answer. But if I did something like 2x plus 1 like that, I think this should give me an error. Multiplication can only be used between coefficients and variables, not other polynomials. So this enforces a particular format on the student's answers. And so you as an author don't have to go through all the work of producing all these error messages and testing this yourself. And of course I could write it in a different order. I could put 1 plus 2x plus x cubed, x squared. That should be okay. I think this one even prevents me from having the same one twice. This one says it's not correct. Well, that's probably because it's not 2. I mean, it's not correct. There's an option here that would say, that would prevent you from having the same term more than once, but it's not actually turned on here. Anyway, that gives you an idea of the kind of things you can do. The documentation for this one is available at this link. That's one example. Here's an example using the ABCD context, which you have to type A, B, C, or D. You can do it in lowercase if you want. So let's just do that. As a professor, I get to see whether these are right or not. The students would normally not get to see these things individually. I got one of these things right. The other ones are incorrect. But if I were to type something that's not allowed here, like X, it should say your answer should be one of A, B, C, or D. So that gives you the student information about this. You shouldn't be able to do lists of these things, I don't think, in this particular one. The answer should be one of these things. Okay. So that tries to help them along. Here's one, the ABCD context, where what you have to do is type in the letters of all the things that are true, or enter the word none if none is true. Of course, the student will start off by typing none without thinking about it, just to make sure that that's not the right answer. That's incorrect. Okay, so now I have to think about the problem. So what of these things are true about the square root of x squared minus 4? Is f undefined at 2? Well, 2 squared is 4 minus 4 is 0. Square root of 0 is defined, so that's false. F has a minimum value of minus 2. Well, the square root is always 0 or positive, so that's false. F is increasing from 2 to infinity. That's true, so I'll put C in here. E has no maximum value. That's also true. So I can make a list of answers that are true. This is correct. And if you were to put something that wasn't allowed, you would get something about your answer should be one of those things. Again, you could have done this as a bunch of true or false statements, but this is another option. This tells you how this works. All right. So when you have a context, you might need to make adjustments to it. For example, add more variables in a multivariable situation. Or, as we've seen, you could change whether the certain things are allowed to be typed, like pluses or minuses. So the current context can be attained simply by calling context with no name. That'll get you an object that contains all the data about the current context. You can change values stored in the context using add or set or remove or other kinds of properties on the appropriate type of object. So the context variables, talking about what variables are defined there, and I'm going to add to that a variable y, and that y is a real number as opposed to, say, a complex number or a point or a vector or some other kind of an object. I can take the variables and set some properties of those variables. I'm setting the properties for y, and the property I'm setting is the limits for y, and the limits are going to be from -1 to 3. Limits meaning this is the range of values that y is allowed to take on, so that when you were doing answer checking, for example, we will only pick points that have y's within these between -1 and 3. You might need to limit what those ranges are if you're using things like square roots or logs or something where the values are undefined. So you might need to say, I want to use y's on this range. So limits would do that. This one line does both of those two at once. It adds a value y, which is a real number, and has these limits. So you could do those two steps simultaneously. The word R instead of add removes any current variables and then adds these two in. So this makes sure that there are no other variables except x and y in this context. So we'll have two real variables, x and y. This next one says take the operators and remove the double star and the hat, which means we can't do exponentiation, at least not through hats and stars. So this would mean the student could not type in something like x squared. They would have to use x times x or something like that. So this would allow you to prevent them from doing exponentiation explicitly. There are a lot of flags for a context. This sets the tolerance to be 0.0001. So that is the relative tolerance that you need to have two numbers within that tolerance in order to be counted as the same. We'll talk about that when we talk a little bit more about the way that answers are checked. Here's adding a string. So if you want to add in the string true, so that the student can say the word true, we'll take strings and add true. True doesn't, these strings don't have any values really to them. So true is just true. This is T, which is an alias to true, which means they could type either the word true or the letter T. And by default, strings can be either uppercase or lowercase, so they could have lowercase true or lowercase t, or lowercase t, uppercase r, lowercase u, uppercase t, whatever they want, any mixture of those things. You can control that with other properties inside these braces if you wanted to. But to add a string in there, someone had asked in one of the forums about adding the word error into their problem. This is how you would do it. Context strings add the word error, this equal greater than sign, and then close braces, open close braces. That'll add the word error as something that the context will recognize if the student types it. All right, so those are manipulations. There are lots of other manipulations you can do. One of the links at the very opening of the page, I think, is to manipulating contexts. If it's not, then following the main link to MathObjects will have details about how to change the context. Here's another way to change it, enabling or disabling functions. So functions can be manipulated in groups. So here we say functions, the context functions disable all functions. So a student cannot type log or cosine or any kind of, or square root or any function. And then enable square root again. So this says turn off all functions except for square root. So they're allowed to type square root, but nothing else. This one would say turn off all functions and then enable what are called the simple trig functions, which would be sine, cosine, tangent, secant, cosecant, cotangent. I don't think their inverses are in this group. The groups are defined on this wiki page. So here are the various groups. Simple trig is sine, cosine, tan, secant, cosecant, cotangent. Inverse trigs are the inverses of those. Hyperbolic, simple, and inverse numeric functions. And then there are some groups like trig is everything in the simple trig, the inverse trig, and the hyperbolic ones. So trig functions as a whole include all of those. So you can enable or disable these things as groups or individually. So here would say disable the trig functions, but enable sine and cosine by themselves. So the only functions you're allowed there is sine and cosine. So you could ask what's tangent in terms of sine and cosine, and they would not be able to type tangent, but they could type sine and cosine. So if we did this first set of ones all and allow square root, and we say write sine of pi over 3 as a fraction, I can't type sine of pi over 3. Excuse me. Or I can type it, but it should tell me that I'm not allowed to use sine in this context. So I can't use sine, so I'd have to say something else, something like square root of 3 over 2. Is that right? So that's correct. So that allows you to ask a question about sine, but not be allowed to use sine in the answers. Regina asks this, a context for trigonometric functions in degrees. Just so happens that Paul has been working on that, so I think by the end of the week we certainly will have that available. So not quite, but almost. All right, so that's enabling and disabling these guys. Some function calls that change the context, other things you can do. For example, parser number no decimals on a context says turn off or check any number that the student enters and make sure it doesn't have any decimal places. So this would prevent them from typing in a decimal number. So for example, if I type 1.23, says you are not allowed to type decimal numbers in this problem. Of course, you can get decimal numbers in other ways. You could say 1/2, that'll get us 0.5, and that's allowed, but I have not typed 0.5. I have typed it another way. Or you could get square root of 2. Well, those are decimal numbers, but I did not type a decimal number to get it. So this is a way that you could ask students to you evaluate something that where you don't want them to plug it into their calculator and give you the number. You want them to type in, pi over 3 or something along those lines. They would not be able to type in the decimal number pi over 3. Another thing you might want is to limit the powers that you want to be allowed. So there's a macro file called limited powers. And this one says operators set and then use limited powers integers only. So in this case, the only powers you're allowed to have are positive or negative integers, maybe even 0. So I can type x squared, but I can't type x to the 0.5. I can't do square rooting that way. So powers must be integer constants, although I could use -2. So that's allowed in this case. Limited powers has a variety of options. You could have positive integers only. You could have different kinds of situations. So these are modifications you can make to the context to allow you to restrict what the student is allowed to do. Oops, sorry about that. All right. Those are limitations. All right, so how does context interact with the correct answers? Context setting applies to the professor's answers as well as the students. So when you're writing a problem and you've limited the context, you have to be aware that that also limits it for you. So that is, the correct answer can only be something that the student can type. So let's look at the source for this one. Down here is essentially the problem. Here we've taken the context numeric, says set the numeric context and give us back the object, change its functions to disable the trig functions, and we've turned no decimals on here, so the student can't type in this number into their calculator and get a decimal, so they're going to have to type this as the square root of 3 over 2. And so here's the statement of the problem. Write sine of pi over 3 as a fraction, but my answer can't be sine of pi over 3. It has to be in the form the student can write. This context does not allow sine of pi over 3, so you can't use it either. So you've got to type it in the form that the student can do. So you cannot use this. Although you could have used this one for reasons we'll see later on. But the answer would show up as a decimal number, and they're not allowed to type decimal numbers, so you better not do it that way, because you don't want to give the students a number that they can't enter, or an answer that they can't enter. Because what you put here is the thing that shows up as the correct answer when the students ask for correct answers after the due date. So whatever is here is important. This is visible to the student at some point. So you need to make this be in the form you want the student to think about the problem. So that's one thing to keep in mind as you're writing these.